Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Esterification involves only the carbonyl carbon, the carboxylic acid carbon. The problem statement explicitly states this. Therefore, the chiral center, the alpha carbon bearing the OH group, is not touched during the reaction. Moving on to the next step. The absolute configuration, R or S, of the chiral center is determined by the spatial arrangement of substituents and their CIP priorities. The sign of optical rotation, plus dash, is an experimentally measured property that depends on how a compound interacts with plane polarized light. Crucially, there is no direct, predictable relationship between absolute configuration, RS, and the sign of optical rotation, plus dash. A compound with R configuration can be plus or dash and vice versa. Moving on to the next step. The chiral center was not disturbed, no bond at the chiral center was broken or formed. The absolute configuration, R or S, remained the same. However, when the ChO group is converted to ChO3, the CIP priorities of the substituents around the chiral center may change, potentially changing the RS designation on paper, but even setting that aside, the sign of optical rotation changed from dash to plus. This change in optical rotation sign occurred simply because the overall molecule changed. Different substituents affect the interaction with polarized light, not because of any inversion at the chiral center. And for the final step, S_N2 at the chiral center is wrong because the reaction involves only the carbonyl carbon, not the chiral center. No inversion occurred at the stereocenter. B, S_N1 at the chiral center is wrong for the same reason, no reaction occurred at the chiral center. C, no diastereomer was produced, the chiral center configuration was unchanged and only one stereoisomer is present. Diastereomers require 2 or more stereocenters with different configurations. The sign of optical rotation changed from dash to plus, not because the absolute configuration changed, but because the optical rotation of a compound is an empirical property not directly predictable from absolute configuration. Changing ChO to ChO3 alters the molecule's interaction with polarized light, giving a different sign of rotation. This is coincidental with respect to absolute configuration, as optical rotation sign and RS designation have no fixed correspondence. Therefore, the correct answer is D. Therefore, the correct answer is option D.